In this lesson, we're going to look at the properties of arcs and chords in a circle, but we're going to first review a couple things. A line segment whose endpoints are points on the circle, remember that's called a chord. And a chord which passes through the center of a circle is the diameter. So a diameter is still a chord. It happens to be the longest chord in a circle. All right, so let's talk about a few theorems. In a circle, or congruent circles, congruent central angles are going to have congruent chords. So let me talk you through how we would prove something like that. If I have circle O, and I have AOB is congruent to COD. So these two are central angles, and we know that these two angles are congruent. Well, I can prove that AB is congruent to CD because one thing we have, and we're just going to talk through it. I'm not going to write a formal two-column proof here. Think about what you know about the radii of a circle. And in a circle, all radii are congruent. So that means all four of these guys are congruent. Well, what triangle congruence is this when I have side and angle and side? Well, duh, it's side, angle, side, right? So I could say that because all radii are congruent, we could say that angle or triangle COD is congruent with triangle AOB, and then we can get the chords congruent by our favorite statement, corresponding parts of congruent triangles are congruent. So that's how you would show or prove that those chords are congruent. Our next theorem says that in a circle, congruent arcs have congruent chords. So this is talking about the arcs. And if you think about it, again, congruent arcs, we know that the measure of the arc is equal to the central angle. So if the arcs are congruent, that means the central angles have to be congruent, and then we're back to what we just proved, where the chords have to be congruent by side, angle, side, and CPC/TC. So just to write some of that down, if AB, arc AB, is congruent to arc DC, then the chord AB, now we draw the flat line, has to be congruent to the chord DC. So look at our symbols. When we're talking about the arcs, we make an arc. When we're talking about a chord, we make the line segment symbol. Okay, the next one. In a circle, congruent chords have congruent central angles. So we're saying the same thing, just starting with different values. So let's try to reason why that is. Here we're starting with congruent chords. Well, again, we have two triangles here, and the other sides of the triangle are made up by the radius, and we know that in a circle, all radii are congruent. So that triangle congruence is side, 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 and then again we can get the angle, the central angle is congruent by CPC/TC. So congruent chords create congruent central angles and congruent arcs, and they all kind of work together. So I just stated this, but we haven't formally written it as a theorem. In a circle, congruent chords have congruent arcs. We stated the converse of that. We said congruent arcs have congruent chords. So it goes to follow that congruent chords would have congruent arcs. So if, in a circle, if AB, chord AB, is congruent to chord DC, then arc AB has to be congruent to arc DC. Okay, the next one talks about a diameter being perpendicular to a chord, and that sets up some special properties. So a diameter that is perpendicular to a chord, it acts as the perpendicular bisector of the chord, so it bisects the chord and its arcs. So the diameter, if I draw any diameter here, and if I draw a chord that's going to be perpendicular to that diameter, a little tough for me to do on here, then the diameter acts as the perpendicular bisector of the chord. It cuts the chord in half, and it's perpendicular, and it also cuts the arc in half. So we can write it out if, and I need to label it here, I have diameter DB and I have chord AC. So if DB is perpendicular to AC, then I can write a couple things. I can say that AE, I'll put E as the intersection point, segment AE is going to be congruent to segment CE, and arc AE, or arc AB, is going to be congruent to arc CB. So a diameter that's perpendicular chord divides everything in half. So we'll look at this example here. I have given CD as a diameter, and CD is perpendicular to AB. We're going to set up the properties that we had up here. Let's say that AB is 8 and EO is 3. We want to find OB. Well, we know this is a right angle. If AB is 8, that means EB has to be 4. So the length of AB is 4. And then, since we have a right triangle like we've been doing all year, if I have two legs of a right triangle and I want to find the hypotenuse, we're going to use Pythagorean theorem. So 3 squared plus 4 squared is equal to c squared. And you're going to end up with a length of 5. So OB is 5. So we can combine a lot of things here. What we know now about chords and diameters, along with right triangle information. So a corollary to that is this, the perpendicular bisector of a chord. So if a chord has a perpendicular bisector, it's going to pass through the center of the circle. It has to. And that is another way that we can actually find the center of a circle. And we'll talk about that in class. So if two chords of a circle, and here's one more thing, if two chords of a circle are congruent, then they are equidistant from the center of the circle. So any pair of chords that are the same length are going to be the same distance away from the center of the circle. And that's the perpendicular distance. So it's hard for me to draw on this little bitty thing. But the perpendicular distance is going to be the same between them. So if AB is congruent to CD or DC, either way, then if I say this is, then they will be the same distance away from O. So if this point is E and this point is F, it's really hard for me to write on this little thing, then EO is going to be congruent to FO. Finally, the converse is also true. If two chords of a circle are the same distance away from its center, then they are congruent. So what that means is if OF is congruent to OE, then AB is going to be congruent to DC. So we went through quite a few theorems today. Some of them should be pretty basic, but others are going to take a little bit more practice to get down, and we will practice all of this when we're together in class.